We welcome you all to National Chemistry Week, held under American Chemical Society, Pakistan chapter, from October 18th to October 24th. Our president is Professor Dr. Usma Ashik from Department of Chemistry at the University of Karachi, and the secretary is Dr. Sajid Jahangir, who is an assistant professor at the Federal Urdu University of Arts and Science Technology. Dr. Rifatara Jamal as the treasurer, and we have two executive members, Dr. Kausar Yasmeen and Dr. Ismail Bohra. Around the globe, Mole Day is celebrated by chemists on October 23rd from 6:02 a.m. to 6:02 p.m. This date represents 6.02 into 10 to the power 23, which is the Avogadro's number. But what's the mystery behind this number? Emilio Avogadro performed experiments and told that all gases experience the same increase in volume by the application of same degree of heat, which meant that equal volumes of gases contain the same number of particles. This was Avogadro's hypothesis. Contrary to the beliefs of generations of chemistry students, Avogadro's number was not discovered by Emilio Avogadro. The first person to estimate the actual number of particles in a given amount of a substance was Joseph Loschmidt, an Austrian high school teacher. He used kinetic molecular theory to estimate the number of particles in 1 cubic centimeter of a gas. Loschmidt constant was determined with a value of 2.68 into 10 to the power 25 meter per cube. Jean-Baptiste Perrin estimated Avogadro's number using Robert Brown's work on Brownian motion. He was the first person to use the term Avogadro's number. Willem Oswald came up with the idea of the name mole, which is a short form of gram molecular weight. A survey was carried out in which the undergraduate chemistry students were asked a simple question regarding how Avogadro's constant was determined. They were given two options, either by counting 6.02 into 10 to the power 23 particles or by using Faraday's constant. Surprisingly, 62.5% answered wrong. They thought it was done by counting the particles. However, it is impossible to count such a large number of particles. It would take approximately 20 quadrillion years to count 6.02 into 10 to the power 23 particles. So, we need an alternative. But first, let us look at what a mole is. A mole is kind of like a dozen, except that there are 12 things in a dozen as compared to 602 hexillion things in a mole. Let us look at how big a mole is. Imagine if we had 602 hexillion jelly beans, it would be as big as the whole planet Earth. But if we look at molecular level, very small amounts contain 602 hexillion particles, may it be atoms, electrons, ions or molecules. As you can see, 12 grams of carbon or 197 grams of gold or 18 grams of water all are equal to 1 mole. Now you must be wondering how different masses contain the same number of particles. The difference is due to the difference in sizes of the particles. Avogadro gave the hypothesis of equal volumes of gases with same number of particles in 1820. In 1833, Faraday carried out his experiment of electrolysis and determined the Faraday's constant. In 1909, Millikan performed his experiment of oil drop and determined the charge of electron. And finally, in the very same year, 1909, Avogadro's constant was determined by Jean-Baptiste Perrin. Let us first look at the Millikan's oil drop experiment. In 19th century, Rutherford performed the gold foil experiment of alpha scattering. The structure of atom was known, but the charge of an electron was still unknown. Millikan modified experiments tried by others and did careful work. He used volatile oil rather than volatile water. The aim of Millikan's oil drop experiment was to determine the charge of an electron. This is a photograph of the apparatus that Millikan used. He used X-rays to ionize the oil droplets. Let us now look at the experiment that Millikan performed. As you can see, oil droplets are sprayed in the upper chamber using an atomizer. Some oil droplets fell through the hole in the upper floor. He then ionized the droplets using X-rays. They now carry a negative charge. As voltage across the plates is increased, the velocity of oil drops slows. At the right voltage, oil drop can be suspended. For a suspended oil droplet, its weight is equal to the electric force applied. Q into E is equal to M times G. M is for mass of oil droplet, G for gravity, and electric field are known. This is how Q was determined. E is equal to negative 1.6 into 10 to the power negative 19 coulomb, which is the fundamental unit of charge of an electron. Millikan found that droplets had different charges, but each was an integral multiple of a smaller charge. The fundamental charge, E, is equal to negative 1.6 into 10 to the power negative 19 coulomb. Now let's look at Faraday's electrolysis. In chemistry, the production of chemical changes by passing an electric current through an electrolyte, resulting in migration of ions to electrodes, is known as electrolysis. During electrolysis, the ions react with the electrode, either by receiving or giving up electrons. The resultant atoms may be liberated as gas or deposited as a solid on the electrode. The amount is proportional to the amount of current passed. If negative ions move towards the anode, they lose electrons and become neutral, resulting in an oxidation reaction. And if positive ions move towards the cathode, they gain electrons, becoming neutral. A reduction reaction takes place. For example, the electrolysis of a solution of copper sulfate. The anode dissolves and the cathode gains mass as copper is deposited. Michael Faraday stated that the mass of a substance liberated at the electrode is directly proportional to the quantity of electricity passed through the electrolyte. M is directly proportional to Q, where Q is equal to Z into I into T, where I is the electric current, T is the time duration, and Z is the electrochemical equivalent. What is an electrochemical equivalent? It is represented by the symbol Z, and it is the amount of substance liberated or deposited when 1 coulomb of charge is passed through an electrolyte. The units are kgs per coulomb, and the equivalent mass of an element is equal to the atomic mass of an element divided by the valency of the element. To find the Faraday's constant, we need to know 4 simple things: the quantity of current passed, the time duration, the charge of ions in analyte, and the change in mass of electrodes. Using this equation, we can know the amount of charge passed through the solution. For change in mass, the reduction in size of anode is equal to the increase in size of the cathode. Using this, we can tell what quantity of charge is required to deposit 1 mole of that substance. For example, 0.13 gram requires 408 coulomb. So, to deposit 1 mole of copper, 63.5 grams is the molecular mass. Using this, we can determine the value 96500 coulomb, the Faraday's constant. This is the charge on 1 mole of electrons, and it is calculated by dividing the charge required to deposit by the valency of that element. 1 Faraday is equal to 96500 coulombs. Faraday is defined as the quantity of charge which deposits or liberates exactly 1 gram equivalent of a substance. So how was the Avogadro's number determined? It was determined by dividing the Faraday's constant by the charge of an electron, and it gave the value 6.02 into 10 to the power 23. This discovery was a major advancement in the world of chemistry. Moles are required everywhere. Thanks to Avogadro that we are celebrating Mole Day today. The bibliography is shown here.